Okay, we're going to have a discussion about rational numbers, and we're going to do some easy operations with them. So it makes sense to start with what is a rational number? Well, the definition is kind of hidden in the word. Right here it says ratio. A rational number is a ratio. So a ratio is when one thing gets compared to another thing or divided by another thing. So a rational number is actually a fraction. And there is a rule. The rule is that that fraction has to be an integer divided by another integer. And you'll see why that's important in a minute. But integers are just the numbers that you're familiar with, whole numbers, 5, 7, 1,000, -20, whatever. So let's write some examples of some rational numbers. How about 1/2? There you go. Or how about the number 7? Is 7 a rational number? Yes, it is, because you can just do this. 7 over 1 is the same thing as 7, and now that's a fraction. So it's pretty broad. Lots of numbers can be rational numbers, but not all numbers. For example, how about the square root of 2? You could just try this trick right here, this 7 over 1 trick, and you could say, okay, well, square root of 2 over 1, there you go, it's a fraction, therefore it's a rational number. Well, while it is a fraction, it is not rational because the square root of 2 is not an integer. You could play around with your calculator all day long and put numbers into it, and you would never get one number divided by another number that would give you the square root of 2. So let's just find the square root of 2. 2 square root. It's 1.41 blah, 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 blah. So you could try numbers until you're blue in the face, whatever divided by whatever, and you will never get that number that we just saw. Just as an example, like 3, 4, 5,000 years ago, the Babylonians, they tried to do the same thing, and they came up with this. They came up with 1 divided by 24/60 plus 51 over 60 squared plus 10 over 60 cubed, and they got 1.41 and a bunch of numbers, which is close, but it wasn't exactly the same. And here's another one. This one apparently comes from where? From India. And you just can't ever nail it exactly. So this number right here, this square root of 2, or the square root of 2 over 1, this is called an irrational number. It's not the most famous irrational number. Another more famous example is pi. Pi is irrational, so you can't turn that into a fraction of one integer over another. So that's the definition of a rational number. So for the rest of this video, I want to be able to do 4 things. I want to be able to multiply, divide, add, and subtract rational numbers or fractions. So let's start easy. Let's do this. Let's do 1/2 times, I don't know, 3/4. Multiplying rational numbers is really easy. All you have to do is multiply across the top, multiply across the bottom, and then you're done. So I'm going to have 3 times 1, which is 3, 2 times 4, which is 8, and that's it. So multiplying, you just multiply across the top, multiply across the bottom, and you're done. Division is almost as easy, but there's a trick. When you see something like this, like let me stick with these 2 fractions. Let's say I've got 1/2 divided by 3/4. When a lot of kids see this, they instantly freak out. They're like, how in the heck am I supposed to do that? Well, some kids will be like, okay, 1/2, that's 0.5, and 3/4, that's 0.75. You could just put those in a calculator. Just for the heck of it, let's see what we get here. 0.5 divided by 0.75. We wind up getting 0.6 repeating. That's 2/3. Okay, so let's just remember that. But anyway, so when you divide one fraction by another fraction, there's a nifty little trick. And the trick is that you take the bottom, the denominator, this 3/4 fraction, and you turn it into its reciprocal. In other words, you turn it into 4/3. You take that 4/3 and you multiply it by the top. So let's do this. Let's do 1/2 times 4/3. So we've got 4 times 1 is 4 over 2 times 3, that's 6. That's reducible, that's 2/3, and actually that's exactly what we got right here when we did it on the calculator. Just to do one more example that maybe kids will find a little more concrete, let's say you had $2 and you wanted to divide that by half of a buck, 50 cents. Well, how many times does 50 cents go into $2? Well, you know the answer is 4. But let's say you didn't know the answer was 4. What could you do? Well, what is the reciprocal of 1 over 2? The reciprocal of 1 over 2 is 2 over 1. So if I just take my $2 and multiply it by 2 over 1, what do I get? I get 4. So this little reciprocal trick makes division pretty much as easy as multiplication. Okay, that leaves me with my last two operations I want to be able to do, adding and subtracting. So let's say I want to add 1/2 and 3/4. I could do it with a calculator, but let's try something else. Let's try it the proper way. One thing I notice right off the bat is that 2 and 4, they have a common number, and that would be 4. 2 and 4 both go into 4. So if I double 1/2, I get 2/4. So I could pretend that that's not even there, and I would have 2 plus 3, and that's 5, and I'd have my 4 on the bottom. So 5/4. So if you add 1/2 and 3/4, you get 5/4. That's the same thing as saying 1 and 1/4, but believe it or not, this is actually better than this if you're doing math. This is called a mixed number, and it makes your math actually harder, so mathematicians actually prefer to use this. Okay, so anyway, where was I? 5/4. What I did here was on the bottom, I made both of my denominators be 4. That's called a common denominator. And you need to do that. You need to have a common denominator whenever you add or subtract rational numbers. Now, this one was so easy. It was, 1/2 and 3/4. It was pretty easy to recognize, oh yeah, 2 and 4, I'll just make them both be 4. But let's say I didn't recognize that. I've got my 1/2 plus my 3/4. There's a trick, and the trick to create a common denominator is to multiply both fractions by another fraction, and that fraction is figured out like this. This 1/2, I'm going to multiply the 1/2 by the denominator over here, so it's going to be 4 over 4. Okay, let me erase my mess here. Oops. So 4 over 4 here, and this fraction over on this side, I'm going to multiply it by 2 over 2. So I'm going to have this. So now I've got 4 times 1, that's 4, and 4 times 2, that's 8, plus 2 times 3, that's 6, and 2 times 4, that's 8. So what I did was I manufactured my own common denominator by multiplying by these fractions right here. Okay, so then what do we get? Since we've got a common denominator, we can just add. 6 and 4 is 10. 10/8, that's reducible. That's what, 5/4 or 1 1/4, just like we had before. I think this is kind of amazing because what you've got going on is, what did we really do here? This 4 over 4 and this 2 over 2, we use that to manufacture our common denominator, but really, what is that? What is 4 over 4 and what is 2 over 2? It's just 1. So if you multiply anything by 1, you don't change it into something else. So basically this little trick here, that's exactly what it is. It's a trick to allow us to create a common denominator. So that trick works for adding and subtracting. So what I did was I snooped around online and I found this website right here. And I want to play these quick little mini videos for you. So let's play this one first. 1/2 times 2/5. Okay, we've got 1 times 2 over 2 times 5. So that's 2 over 10. That's reducible. That's 1/5, and boom, we're done. Pretty easy. What happens up here if you don't use numbers, if you just use variables? Well, some people might even say it's actually easier. You can just write the letters. We've got A times C over B times D, and we're done. So that's it with variables. So that's why multiplication is a breeze. Division. Let's do this one first because we talked about this already. We've got 1/2 and we're dividing by 1/6, so we're going to switch that around to 6 over 1. And now it's just a multiplication problem. 6 over 2, you wind up with 3. And then the same thing works with variables if you just use letters. We've got a over b. We're going to times that by d over c. We're going to switch that to its reciprocal. And we wind up with a times d over b times c, and that's it. So now let's jump down to adding and subtracting. So here is where we have to use a common denominator, because we can't just add 1/2 to 2/5. So what are we going to do here? We're going to multiply both of them by the denominator of the other fraction. Let me pause this a second. So 1/2, we're going to multiply that by 5 over 5. And then the 2/5, we're going to multiply that by 2 over 2. So then now it's just going to be a multiplication problem. We can finish it up. 1 times 5 is 5. 2 times 2 is 4. 2 times 5 is 10, so our denominator is 10. We get 9/10. We get the same kind of thing when you use just the letters, just the variables. We got a over b plus c over d, so we're going to multiply the a over b by the d, and we're going to multiply the c over d by the b. And we wind up with what? See, it's going to be over b times d. That's going to be on the bottom. So we're going to have ad plus bc over bd. I guess you could argue that in this case, just using the numbers looks easier than the variables there. I think I'd probably agree with you. So this website is called mathisfun.com. I'm sure you all agree, math is fun. And let's watch the last little video right here. 3/4 minus 1/5. So this time they went lightning fast. Why did they do that? Well, let's see here. We're going to multiply 3/4 by 5 over 5, and that's where that 5 comes from. And we're going to multiply 1/5 by 4 over 4. That's where these 4's come from. So they just left this step out of writing everything right here. So you wind up with 11/20. Okay, so there is your introduction to rational numbers and doing some easy operations with them.